in my background, I'm metallurgist, but I'm not confident to say I'm metallurgist because I'm more of working on applications of minerals. I did my PhD for photoluminescence application for gas sensors like that, and currently I'm working on energy storage application. I'm going to show you what we are doing in CSIR, energy storage group. Basically the transition metals. I focus on the manganese and titanium because these are very rich minerals in South Africa. So the title of my talk is going to be the transition metals, manganese and titanium based for energy storage applications. So I would like to give a brief on some information on major mineral resources for lithium-ion battery, like as I said, on manganese and titanium. Then I will talk about the battery technology drivers. I'm going to focus on electrochemical energy storage systems, specifically on lithium-ion battery. We more study on lithium-ion battery. Our research is more on lithium-ion battery. You may remember that CSIR, South Africa was the best in the world in terms of patenting and discovering the lithium-ion battery and in general battery technologies. CSIR was one of the pioneers in the 80s. Then CSIR stopped the research on batteries. Then in 2009, we restarted it. And by now we are doing a very good research. We can say our group is working, I can say, very competitive, world-class research. So I'm going to talk about overview on CSIR engagement or activities, and I'll show you a brief some of the achievements on electrochemical energy technologies groups technologies, and finally I will give you the summary. As I said, the major mineral resources, geographical locations. When you see the manganese resource, about 80% of the known world manganese resources are located in South Africa. Therefore, South Africa, it makes sense, South Africa to do a lot of research and push a lot of technology on energy storage. The remaining other important manganese deposits are in Ukraine, Australia, India, China, Gabon, and Brazil. So you can see that 80% of the manganese resource is in South Africa. And when you see also the titanium, the manganese is the cathode part. The titanium will be used as the anode part. And titanium is the 9th most abundant element in the Earth's crust. The most important minerals for mining titanium are rutile and ilmenite phase, and the top producing countries of these ores are Australia, South Africa, and Canada. So you can see some of the data here. The world titanium reserves. There you can find South Africa. It has, I think, the third reserve in this case, and it is also one of the top producer for production the ilmenite type of titanium oxide. titanium resource. So what are the technology drivers for battery? In the automotive industry, one of the drivers is the automotive industry. The electric vehicle market to grow, the study shows that the electric vehicle market to grow 14-fold from 10 billion in 2014 to 140 billion US dollar by 2020. And the other thing is there is a feasibility approach to curb air pollution. There is a tendency, agreement to reduce the air pollution. So there is a lot of opportunities there. Therefore, the other thing is falling battery EV costs due to mass production. The lithium-ion battery especially, the price has dropped dramatically. I will show you that in the coming slides. And the other thing is there is a lot of achievement in the improving the product range. The product range in this case is to the battery usage before charging. The range to drive has improved through research. And there is also ongoing expansion on fast charging infrastructure. In that case, now this, especially the LTO, lithium titanate, is showing a good achievement to use in the high energy electrode materials. So this is the interesting startup, or I can say breakthrough in when Tesla announced opens in 2017 the battery energy storage Gigafactory. This factory is located in Nevada and it employs up to 6,500 people. And the payment, it can pay $25 per hour. And it builds lithium-ion batteries. The cost to build this Gigafactory is about $5 billion US dollar. And it's pitching in $1 billion US dollar plus incentives because of starting this Gigafactory. As you know, this is the Tesla CEO, Elon Musk, the South African entrepreneur. When they started this Gigafactory, they are able to, it is 100 billion US dollar economic benefit over 20 years. It will create this much benefit. And the factory will help Tesla move closer to mass producing and to reduce the price of a fully electrified car to 35,000 US dollars. This is almost comparable to what we get in the market. And as you see, what we said, it can work on up to 200-mile range. The limit, the target is 300 mile per range, which means with one charging. But they achieved 200-mile range, and they produced, I think they manufactured Model S, Tesla Model S cars, and they got their technology got very acceptable, attracted a lot of customers. And what they did is they tried to make everything, they start from the electrode material. They manufacture inside the factory everything from the raw material the raw material in this case is, as you say, the cathode material, the anode material. So from that they start and they make the battery. It is almost fully automated factory, and they get everything inside that Gigafactory. That's why they are economically, they can reduce the price of the car. And the other, the drivers is the application of battery in utilities, like battery storage to grow from 0.5 billion in 2015 to 14 billion market by 2020 due to increasing renewables investment. So the battery can be, it can be complemented with solar cell, so that it will have a best application. You can buy your battery to store during the day, and you can use it when there is no sun during the night time. And this application is for residential battery plus solar application. As you see here, the technology has grown so that you get the battery to store, to electrify your home. Just if you see the Tesla model, you can just post it on your wall, then it can electrify the whole your house during the night time. So the technology has grown really very nicely. And the other thing is you can use that like microgrids. You don't need to, especially in game reserves like that, they use the battery as well as the solar, then they will have microgrids, their own microgrids. Here we can see that the lithium-ion batteries to cross $100 per kilowatt hour in 2018 for residential solar plus electric battery cost, which is competitive with grid electricity by 2020. When you see there, energy storage prices are fallen rapidly, allowing new combinations of solar, wind, and energy storage to outcompete the cost of coal and natural gas plants, according to the new study. There is a lot of investment on the research, on R&D, which paid off. As you see, the cost of a lithium-ion battery down from 10,000 per kilowatt hour in early 90s to $100 per kilowatt hour in 2018. So this shows by 2020 the combination, the battery, solar, and wind, it is going to be competitive with the traditional way of the power we get, the power source we get. The other key drive or the market opportunity is in Africa, as South Africa is in a better position, as we said, in terms of the resource, the raw materials, and the technology. There is a huge opportunity to pursue in this area, in the energy storage, to achieve or to get advantage in the African market. As you see, only 20% Africans have access to electricity. This is the World Bank report, especially the sub-Saharan. They are not connected to electricity. So there is a lot of opportunity over there. You can see most of the dark red areas, they are not connected. Greater than 70% of the population is not connected to electricity. So let's see the overview on CSIR activities. The objectives of CSIR energy storage is the technical to produce high performance manganese-rich electrode material for lithium-ion battery. What we mean, we get the South African raw material we make value addition. We value add by synthesizing, we make it to electrode material. The socio-economic application, it assists local SA industries via value addition to mineral beneficiations. Notably, we use the electrolytic manganese dioxide, locally produced, and manganese salts, which are produced locally. And that actually makes a job creation. The competitive advantage of South Africa, access to key raw materials like EMD, electrolytic manganese dioxide, titanium, as well as fluorine. There is also another producer, South African producer, which makes lithium manganese nitrate solution. We also work on that. So access to key African markets, especially sub-Saharan Africa, and we have a unique IP that reduces cost. So we have now patented a lot of patents in CSIR. We use that to scale up, then pilot plant, so that we are really wants to, there is a DST, energy storage roadmap, which will push to create those spin out from this our technology. So we expect by possibly 2025 to get our technology to be out for a market. So this is just the lithium ion value chain. You see here the position of the CSIR in the value chain is a semi-manufacturer. We are actually planning to manufacture the anode, electrode material, and the cathode and the anode from manganese-rich and from titanium-based materials. We prepare that if we are able to make those factories, those industries, that will be a great achievement for South Africa. That is where we are directing. So we are working in partnership and collaboration with academic, University of Western Cape, Nelson Mandela University. These are, and UP, we train students, PhD, master students in these projects with overseas universities like National University of Singapore and in Belgium, as well as industry. We are working with TIA. TIA is funded our, for 3 years, our project. This is the scale up of lithium manganese nickel oxide, LMNO high. We have our patent, and we have now in a position to pilot plant. We have done every economic study, everything, and we are in a position to pilot plant. And we also use we have collaboration with Bushveld Manganese, which I told you, the aqueous manganese nitrate solution, and we developed our patented synthesis method, which is applicable for scaling up and pilot plant. The major research, our research area, the cathode part, because the cathode, actually the cost of the cathode is almost 25% of the entire battery. It is where the cost, 25% of cost is there. So we work on most of this manganese, more of manganese-based materials, because we benefit from manganese. And our laboratory is located in Building 15. We have this energy storage research laboratory. We have all the synthesis, well-equipped synthesis laboratory with important equipments. We have here, as you see, the furnace, high temperature furnace and reaction devices, systems, all the microwave systems. We do all synthesis inside our laboratory. We have also the characteristic material characterization facilities, like as you see, we have AFM, we have XRD. We do all, whatever material we synthesized, we did test whether we have succeeded to, we have formulated, we have acquired that required material. These are our PhD students. Here down, she completed her PhD. She is now in Sweden. She is doing her postdoc. The work we are doing is very, as I told you, it is high-level research. So our PhD graduates are in America, in England, in Sweden, like that. What we produced, they are very competitive. They produce a very good papers, research outputs, so that they compete internationally. This is what they do, characterization. This, as you see, this is the battery tester, which our PhD student is testing her coin cell testing. And this system, this characterized testing system is very expensive. One of the top testing system. We analyze our systems with a state-of-art testing facilities.